Good morning, everyone. We're going to get started now. We have still got a few more people coming in, but we'll just do a couple of housekeeping things before we get started anyway, so no one will miss out on too much. So my name is Alice, and I'm the Environmental Product Specialist at Bluesky. Just to let everyone know, the webinar is being recorded, and we will share this with attendees afterwards, along with the slides. Throughout the presentation, if you do have any questions, please feel free to put them in the Q&A or the chat. We will have time at the end for a Q&A session as well. But thank you to everyone for coming along, and a big thank you to our speakers who have volunteered to take part today. So this webinar is focused on Bluesky's environmental datasets and their real-world applications to helping local authorities deliver green space strategies. This includes the National Tree Map, the National Hedgerow Map, and our recently launched 330-300 analysis tool. I'll be joined by representatives from both Dudley Metropolitan Borough Council and Aberdeenshire Council to showcase their real-world applications of the data. So the first product is the National Tree Map. NTM is a unique comprehensive dataset of trees above 3 metres in height, which provides information on location, extent and height of each feature. It's created using a combination of Bluesky's core products, including our aerial photography and height models, and innovative algorithms and workflows designed by our team of specialists. The data is updated in line with our 2-year capture programme, ensuring it is the most up-to-date and accurate tree dataset available. It's also consistent with base data layers provided to local authorities through APGB. So NTM is derived from those APGB datasets that Bluesky capture, which allows for consistency across spatial datasets used within the council. Although it's quite complex to create, the data itself is actually very simple to use. We provide it as 3 layers. So the first layer is your canopy polygons layer. This represents the individual tree canopy. Second is your idealized crowns. So these are canopy polygons represented as perfect circles. This is particularly beneficial for kind of ease of interpretation and visualization. And finally, the points, which represents the center of the canopy. Each feature is attributed with a unique ID, max height, mean height, and canopy area, as well as additional attributes. These attributes are all calculated from the canopy polygons layer and applied to the other 2 layers, so they are consistent across all 3 layers. We also provide the data capture as an attribute to allow for monitoring, to allow for full transparency of what date the data was captured. This is particularly beneficial for applications where you need to understand changes in canopy cover over time or at different times of year. I've got a few hands up, so I just want to make sure that everyone can hear me and everything is okay. To the other presenters, can everyone hear me okay?
Yeah,
yeah,
all fine, yeah.
Perfect. Just had a few hands up, so just wanted to check that. If you do have any questions during the talks, please feel free to just put them in the chat or as part of the Q&A. So the data is provided as a shapefile in British National Grid projection, but we can provide it in other formats as well, such as GeoPackage, GeoDatabase, or CAD formats such as DXF. So on the screen is a preview of the data. So this is showing the crown layer overlaid on top of Bluesky imagery. So those are those idealized circles for ease of interpretation. Each tree is attributed, but here I'm just showing you 2 of the attributes and only 6 of the attributes. Sorry, 2 of the attribute tables and 6 of the attributes. The first attribute you can see is the NTM ID. This is the OS1K tile and the coordinates of the tree. So this is particularly useful for applications where you've collected information in the field and want to link it back to NTM. The data is provided as a GIS layer, so you can upload the data into a collector app and then collect data for each tree to match it to the ID whilst you're in the field. The second and third attribute is the height, so you have both max and mean height. The max height is often used for worst case scenario mapping. So one example is tree fall area for management along highways. So using the max height, you can create a buffered area to identify risk zones. And therefore, if those zones intersect with highways, properties, public footpaths, or anything else that you're interested in. The mean height is often used for representative mapping, particularly applications such as carbon capture and 3D visualizations. You then have 3 other attributes: the standard deviation, so the variation in height, the perimeter, so the edge boundary of that canopy, and then the area. So all 3 of these are really good for statistical calculations. One example is the area, which can be used for canopy cover. So this can be done for a discrete AOI or for the total area. For example, if you wanted to know the canopy cover of a park, you can extract all trees from the park and calculate the total area. Or if you wanted to do it on a ward by ward basis, you can join the NDM data to the census data to calculate the total canopy cover in each ward. So using the data for these statistical applications is great for visualizations to identify areas for prioritisation. We first started creating the National Tree Map in 2011 to address the challenges of subsidence in the insurance industry. But it became apparent quite quickly that there are lots of other industries besides insurance who could use this data. Over the past 14-15 years, the product has grown significantly and become an important dataset in many industries. So this ranges from renewable energy and the environmental sector to industries such as utilities, design, forestry, and of course, government. Within all of these industries, the data can then be used for multiple applications. So I've already touched on risk management, such as tree fall highways. I've touched on aiding data collection using collector apps, 3D visualizations, and canopy cover. But you can also do the likes of carbon capture calculations. So Nottingham University, in collaboration with the council, have recently used NTM to calculate street tree carbon and how trees can reduce the urban heat island effect in the city centre. Which leads me nicely on to environmental modelling. So projects such as urban heat islands or flood risk and much more. One example is Cardiff City Council, who have used the NTM to predict leaf fall and therefore plan drain cleaning cycles to reduce street flooding. This specific application shows just how versatile the data is when combining it with other data sets. There are so many applications for the data, I could do a whole webinar probably on just this product. New applications are regularly being discovered. Someone told me recently they use it for line of sight analysis to help plan tree trimming cycles to ensure that speed cameras aren't blocked. But we do have 3 products, so I'm just going to quickly highlight a few applications that are beneficial for local authorities in particular. If there are any others that I don't mention or anything that you're interested in, please do put a message in the chat or drop us an email after the webinar. So firstly, you can combine the NTM with other data sets. As the data can be downloaded and put into your own GIS system, it can be overlaid with other data. So the example on screen is with an OS map, which is particularly beneficial for planning. One example would be overlaying data sets with a new housing plan. Councils can use it to identify which trees on a housing development might need to be removed to allow for buildings, and therefore what number of trees or canopy they need to plant to replace those at a loss. You can also overlay it with census data to allow for monitoring of equitable tree cover, similar to the work done by Birmingham City Council, who have created an urban forest master plan. The data can also be used for visualizations. Due to the number of attributes, it can be symbolized in a multitude of ways. The example on screen is for biodiversity mapping, with the trees symbolised by height. This specific project was for Blenheim Palace to understand areas that are preferential for purple emperor butterflies. These butterflies live in the tallest trees on the highest ground, so using a combination of our digital terrain models and our NTM, we were able to identify those hotspots to predict where the butterflies may be for conservation and protection. This was particularly beneficial for the GIS team at Blenheim Palace to have the data visualised by height so they could use desktop analysis. The final application I want to highlight is one I've already touched on, but is really important and is calculating statistics such as canopy cover. The NTM dataset is over 90% accurate when identifying tree canopy and for calculations such as canopy cover. As already mentioned, this can be for discrete area or total area. One example is Waterford City Council. They use the data to calculate canopy cover across the city, with an average of only 12%, but target set to be 20%. They were then able to combine the NTM and the statistics calculated using land use zonings, and the council have been able to identify suitable areas for planting, such as open spaces and road verges. Other statistics can also be calculated using NTM to provide similar applications. But many of these applications are interconnected, so you can calculate the carbon capture using the height values, which can then be added as an attribute, so symbolised, and can then be overlaid with planning to identify carbon hotspots and therefore prioritise where to plant trees. I'm now going to hand over to Louise from Dudley Metropolitan Borough Council to just give us a brief overview of how they have used the data.
Good morning, my name is Louise Tout and I'm GIS Officer for Dudley Council. My main role in the council is supporting our corporate GIS users. I do a lot of work supporting our 3 main sections that are interested in trees, namely the ecology section, street trees and the tree protection officer in planning. The National Tree Map has become a vital data set for us and the teams we support. Trees are at best undervalued and sometimes even seen as a nuisance. 3 issues we face as a council are as follows. Green infrastructure is often poorly quantified, undervalued, and rarely seen as an asset. The more spatial information we have concerning trees, the more we can begin to tackle this and view the management and promote, enrich, and promoting our green infrastructure. We're all very busy looking at roads, buildings, and addresses in the local authority, and it's important that we've got spatial data quantifying our green infrastructure too. We've around 360,000 trees in our borough. It would be too costly to survey every single tree because it would take a surveyor hundreds of working hours. For the majority of our trees, we don't need a comprehensive survey of them. We just need to know their size and their location. More and more government targets and policies are coming into force, such as biodiversity net gain, canopy cover targets, and our own planning policies. Again, it's important we understand where our trees are and what size their canopy cover is and what size the tree is. So I've picked 4 projects that I worked on last year. The first one, for the next slide, that's it. We were given a criteria for where tree planting was of most use. The National Tree Map data enables us to see where our current trees are. We can then combine this with other data sets to find optimum planting areas. In this example, we combined it with ownership information, Environment Agency flooding data, planning data, or even geology data, for example. This desk-based analysis saves so much time. Site visits can then be conducted at the most likely sites for planting. The second example I've got is in the latest local plan, our planning management had decided to change the policies governing the replanting of trees on development sites. The old rule was that 2 trees needed to be replanted for every tree felled. But now developers are required to at least match and in some cases increase the percentage of canopy cover per site. This should hopefully give us a better outcome for increasing canopy cover across the borough. Using the planning application boundaries and taking area measurements in the GIS, we can give accurate estimates of current canopy cover to allow the planning officers to condition this in their written approvals. In this fictitious example, the current canopy cover is about 22%. So part of the planning officer's recommendations could be that this needs to be increased up to, say, 30%. The next example, we did some work for our green care section. They'd been invited to bid on some funding for tree planting. The criteria for the funding had been set and we were asked to identify areas in our borough of high deprivation and low canopy cover. We combined the Office of National Statistics Index of Multi-Deprivation data with canopy cover to get figures for canopy cover percentages, showing too the areas of the borough that are within the top 10% most deprived areas in England. This provided clear analysis for the bid document and showed that we understood our borough and could identify where planning and funding was needed. Our last example was some analysis work that was needed for public health. They'd been asked to plot some NHS data they received showing deaths due to heat or respiratory issues. They'd assumed that in areas of high canopy cover, there would be fewer deaths due to the heat protection trees provide. We were able to create a workspace for public health that contained the National Tree Map canopy cover, along with other data we hold, such as air quality hotspots, green spaces, and also our local and nature reserves. We also made a selection of the NTM point data just to only select trees that fell within residential properties. Looking to the future, we do see a lot more uses for National Tree Map, and we have got a couple of aspirations. This is currently quite underused in Dudley, but eventually we would like to work more on making 3D views using the height information stored in the National Tree Map. This could be very useful for regeneration and design purposes, and also visualising new planting schemes and helping to suggest suitable species for planting due to the height that it's predicted to grow. Our second aspiration, there's long been talk of using the infrared information captured when the aerial photography is flown to determine what species of trees are present. This would be so useful. As we said before, it's not practical to survey every single tree in the borough, but if we did have some information on what species a tree was, it would make the data invaluable for us. For example, the recent issues we've had with ash dieback, we could have filtered the tree map to show all the ash trees within our borough and see where their location correlated with areas of high footfall, such as schools or main roads. We could have then used this information to target the ash tree condition surveys and create priorities. That's the end of my presentation, and thank you for listening.
Thank you so much, Louise. That was fantastic and very, very informative. So the second product we're going to talk about today is the National Hedgerow Map. So NHM was launched only 6 months ago and is the only hedgerow map currently available in Great Britain that can be used to accurately measure carbon storage due to the volumetrics provided in the attribute table. It provides information on the height, extent, volume and location of all low vegetation between 0.5 metres to 2.99 metres. NHM does come packaged with the NTM, which provides a comprehensive understanding of all trees, woodland, hedgerows and other low vegetation. But this also means that there is no upper limit on the vegetation height, and therefore it's just separated into 2 separate layers, the NHM up to 2.99 metres and the NTM above 3 metres. NHM is provided as 2 distinct layers. The first layer is the vegetation polygon, which is for all low vegetation features, and it details the exact extent of each feature. The second layer is the centerlines, which is for hedgerow features only. Any features classified as a hedgerow by DEFRA are attributed with a centerline and length, which is particularly beneficial for applications in ecological mapping. The centerlines are created using NTM and NHM, and therefore mature hedgerows above 3 metres in height and hedgerow trees are included as part of the centerline, as in line with the DEFRA definition. As I mentioned, it does come packaged with the NTM, so you do also get all 3 layers of the NTM, so the canopy polygons, crowns and the points. Each feature in NHM is attributed with 12 attributes, including volume to facilitate those carbon calculations and the data capture for traceability and trackability. Just like NTM, NHM is updated in line with our 2-year capture programme, is consistent with base layers provided through APGB and provided as a shapefile format as a standard. On screen, you can see the polygon layers of both the NTM and NHM together, but symbolised differently. Without NHM, the hedgerows would be missed, giving only a partial understanding of the vegetation cover in the area. Using these 2 datasets together increases the number of applications, including ecological mapping, habitat connectivity, planning, nature recovery strategy, biodiversity net gain planning, and so much more. This area highlighted on the screen has fantastic connected hedgerows, but the data is also beneficial in areas where hedgerows might be fragmented or there is low habitat connectivity. Combining the datasets together enables desktop analysis to be undertaken for nature recovery and habitat connectivity. Having a polygon layer and a centerline layer allows you to identify low vegetation as well as hedgerows. The features without a centerline might be scrub, bushes, heath, orchard trees or other low vegetation. This is particularly helpful in urban areas, as it can be used to monitor and track public planting areas, community orchards, or even gardens. Research suggests that depending on the city, gardens account for between 15 to 40% of urban areas, and nearly 80% of all green space. Vegetation data often misses this lower vegetation due to height parameters, such as the 3-metre parameter in NTM. Having NHM alongside NTM provides an extra level of granularity when looking at vegetation cover. There are also potential applications and there's lots of research in managing and monitoring invasive species. Although species isn't an attribute in NTM or NHM, the other attributes in the data alongside a dataset such as aerial imagery available through APGB could be used to identify these hotspots where the species are present, such as rhododendron. The second layer in the National Hedgerow Map is the centerlines. So these lines provide information on total volume, length and average height, and are particularly helpful for applications such as conservation. The image on the left was created using a tool in QGIS and the NHM centerlines. This tool identified gaps in the hedgerows and created linear features where those gaps are. The 2-line datasets have then been symbolised differently to identify hedgerow gaps to aid conservation and restoration projects. The image on the right is the line symbolised by height, with trees also shown symbolised by height. This represents just how comprehensive the data is. There are studies that suggest that hedgerow trees store more carbon than street trees and advise on spacing for these trees. The two datasets combined can be used to identify hedgerow trees by cross-checking the NTM polygons and NHM centerlines. These trees particularly can then be managed and protected, and areas where there aren't trees can be prioritised for tree and hedgerow planting. This is particularly important with government targets for tree and hedgerow creation, and making sure you're planting these trees in the best place is so important. Being able to prioritise these locations quickly using desktop analysis with the likes of NTM and NHM is crucial. Potential applications for the NHM data vary and go beyond hedgerow monitoring, management and restoration. Hedgerows are also important for flood risk, wildlife corridors, habitat monitoring, carbon storage, hedgerow creation, and I could go on and on. Early adopters of the dataset have used it for applications particularly around urban hedgerows to reduce noise mitigation, agricultural land management and carbon sequestration. Both NTM and NHM have unique applications as standalone datasets, but when using them together, a wide range of applications becomes possible, including nature recovery strategy, biodiversity net gain planning, and others that I've already highlighted. This is one of the reasons why we do provide the two datasets together to allow our customers to get the most benefit out of the datasets. One of the standout things we have seen since the launch of NHM is how beneficial it has been for filling a gap in the market. There aren't other hedgerow datasets available that provide both 2D and 3D information. As NHM does provide this, the data can be used for a multitude of applications, particularly carbon calculations and habitat classification. One example is the work that the Environment Partnership have been doing to support baseline carbon sequestration assessments, as well as potential implications for biodiversity net gain legislation for their customers. Using the National Hedgerow Map, TEP have been able to undertake ecological assessments and consider BNG early on in the planning process, which has saved them time and money. They've used both the NTM and NHM datasets together in order to complete initial desktop reviews of all habitats and provide strategic spatial insights before on-site surveys need to be undertaken. The final dataset we're going to talk about today is a new dataset that we launched at the end of last year, and it's our 330-300 analysis data. The 330-300 rule is a research-based rule developed in 2021 by the Nature-Based Solutions Institute. It provides a guideline for urban greening and has been widely adopted as standard practice across Europe. However, in the UK, the adoption has been much slower. The rule states that everyone should be able to see 3 trees from their home, have 30% canopy cover in their neighbourhood, and be no more than 300 metres from a green space. Using NTM and a combination of other datasets, Bluesky have developed a tool to analyse the 330-300 score for anywhere across Great Britain. This analysis is provided as GIS layers for all neighbourhoods and buildings, as well as a PDF report of key statistics and a guide to using the datasets. Attributes are provided in all 3 components of the rule, plus an overall score for each neighbourhood and building, which is particularly beneficial for applications such as planning and prioritisation. For example, neighbourhoods and buildings can be filtered or symbolised based on the score. Therefore, the user is able to give each neighbourhood a priority based on that score, such as for tree planting. So neighbourhoods with a score of 0 might be given a maximum priority, and neighbourhoods with a score of 3 a minimum priority. The data can also be combined with other datasets such as public health indices to provide a comprehensive understanding in aiding sustainable urban development. The first layer is the neighbourhood layer. Each neighbourhood is attributed with how many of the buildings meet each rule, as well as an overall average score and canopy cover. This is particularly helpful for community engagement, but I'm not going to go into any more detail on this now, as I know it's something Aberdeenshire Council are going to talk about, so I'll just talk about the other applications and leave that to them. The neighbourhood layer is also great for prioritisation, as already mentioned. So because you can symbolise the data based on canopy cover, score, percent of buildings, or any of the attributes, the visualisations can then be used for urban planning to identify areas that might need more trees or more green space. The neighbourhood boundaries that we use for this analysis are the ONS census boundaries. So this does allow for the data to be combined with other statistics, such as the index of multiple deprivation. You can then combine these datasets to help with planning equitable tree cover and monitoring government targets over time. The second layer is the buildings. So on the screen, the buildings are symbolised based on their score from 0 to 3. Each building is attributed with information about the 3 rules, the score, as well as the raw data. This is really helpful for identifying hotspots within neighbourhoods. So using that neighbourhood layer, you can identify the areas that in need, but then having that high granularity of data in the form of buildings allows for further prioritisation. This is also beneficial as you can see how many buildings meet each score and therefore what you need to prioritise, whether that's canopy through the creation of tiny forests or tree numbers through planting street trees. Similar to both the NTM and NHM, the data is provided as GIS layers, so it can be loaded into your own system and shared across the council. This means that anyone in the council can use it, from planning departments to green space teams, community engagement teams, and you can focus on a specific area or the full boundary if required. I've only highlighted a few of the key applications here, but there are a number of different applications for each layer and each attribute. The data is provided with a GIS guide, as well as guidance on different applications to help you get the most out of it. It was designed with local authorities and planning departments in mind, and we want to be able to help provide valuable information that can be used during desktop analysis to meet government targets and encourage community engagement. We do imagine there'll be a number of applications revealed as the dataset is adopted by our customers. But just like both the NTM and NHM, if there are any applications you want to discuss further, drop a message in the chat or contact us after the webinar. I'm now going to hand over to Fiona and Eleanor for our final presentation about how Aberdeenshire Council are using the 330-300 analysis data.
Hi, thank you. So I'm Fiona Turnside. My colleague Eleanor Monroe and I work in the Natural Environment team in Aberdeenshire Council, which is in North East Scotland. And for a while, our team have been looking at different tools that we can use to try and raise the profile of trees. The natural environment tried to build the engagement both internally within the council across services and also with our communities. So it's been great to work with Bluesky on this new 330-300 analysis tool, testing it out on one of our larger settlements in Inverurie. We don't have much time to go into all the different things that we've been able to do with the data in the short time that we've had it, but I'm just going to pull out a couple of things. I'm going to mention a bit of what we've been doing internally, and then hand over to Eleanor, who'll talk a little bit about our community engagement. But before we do that, I just thought Alice mentioned there about the fact that it comes with a report and a GIS guide, and that has been hugely beneficial to us. Eleanor and I are tree experts, we're not GIS experts, so this information has been really, really helpful for us to basically to work out what we can do with the data, to play around with it, to interpret it, to filter it, to show different things in different ways, and just being able to run projects that we probably wouldn't have necessarily known how to do. So things like let's have a look and see what the settlement looks like with a 20% canopy cover or a 40% canopy cover, or if we're looking at a distance to an open space of 200 meters or 400 meters. So being able to filter that has been really helpful. So internally, Aberdeenshire Council have recently adopted a new council plan, which has a place-based approach to planning, looking at the individuality of specific areas and making sure our services are aligned to what's needed. There's huge variation across our large geographic area. And as part of this, we've been developing corporate place plans for each of our 17 academy settlements, bringing together council services to look at what we've got, what's needed, what the priorities are. And we've got a lot of baseline data that's included in those corporate place plans. Often trees, natural environment, as Louise mentioned, they're often seen as liabilities rather than assets. They're often not included in that baseline data. So what we've been able to use this 330-300 analysis as part of that is just to be able to provide the baseline data to give a brilliant, easily accessible visual representation of the state of the urban forest in Inverurie, to highlight accessibility to green spaces, to show both trees within the public realm and the private realm. And sharing this data has just been like a really tangible, accessible way for people to engage with it. And that has really raised the awareness and interest in trees. And in many ways, it's widened the understanding of responsibility for trees across council services. Often it's, we can quite often end up being siloed into different services deal with different aspects, and this has allowed us just to recognise that different services have the trees and urban green space can be of benefit to their delivery of their service, and therefore they have a responsibility in how they can protect and manage it also. And as part of this process, we've had interest not just from the services you would expect, like our sort of operations team and our landscape services, or in our policy planning, but we've also had interest from our education service, who are keen to look at what the green spaces close to schools are and look at active travel for people walking to school, and that all impacts in terms of distance to open space, canopy cover within that area. And also with our colleagues in our health and social care partnership, who are looking at opportunities to use green prescriptions, and have found value in identifying areas with high canopy cover and priority areas for new tree cover, as this tool has been really beneficial to them also. So the success of embedding the principles of 330-300 into our corporate place plan for Inverurie, which was one of the first ones that's been developed, hopefully allows us to show the value of this work, and we're now looking to try and roll that out across our remaining 16 academy towns in Aberdeenshire. I'll pass over to Eleanor for what we've done with communities.
Thanks, Fiona. So yeah, following on from the work that Fiona's done, or Fiona was talking about there with the corporate part of the corporate services within the council, we also got asked to speak to a joint meeting of community groups in Inverurie who are all involved with community development and environmental work within the town. And it was largely to talk about the canopy work that we've been doing, but we were able to incorporate the 330-300 tool as well, and it became a key part of our presentation because of the clarity of the imagery that we were able to use. So we used it in conjunction with tree equity so that we could compare the canopy cover very clearly with a lot of the background statistical information from tree equity, so that they could see the inequalities in canopy cover and the benefits of trees just across the town. So it was a very, very clear tool to be able to use. The ability to zoom in is a feature that the communities really appreciate because it takes it right down to the level of where they are. And being able to focus in even right down to the individual house level, because the first thing people want to do is go and see whether their house where they live actually meets the requirements. So that's the start of getting them engaged in the whole project and the whole work and the value of trees. So this was it was a real benefit that way, just the clarity of the information, and the community engaged with it really, really well. And as you can see from the image that we've got on that slide, it's very good at demonstrating that privately owned trees, garden trees, are an important part of the urban canopy or the urban forest, and it's not just trees and public open spaces. So moving forward from that, the tool is really useful for getting people engaged and helping build interest in tree cover and the benefits of trees across the town. The community groups that we were speaking to have expressed an interest in developing local place plans, which is the equivalent of neighbourhood plans down in England, which will then feed into the local development plan, and they have a key interest in the environment as part of that. So the data out of the 330-300 will be a very important baseline figure for their development of the local place plans. And linked with that, it also provides a very, very strong evidence base for us to prioritise where we want tree planting to happen in conjunction with the communities. Very quick run through, but that's how we've got the Inverurie community engaging with this tool so far. Thanks, Alice.
Thank you both. That was really interesting and a great presentation. So just to kind of round everything up, what are the next steps for Bluesky? So our environmental products continue to be a focus. There are new technologies and methods, and we're constantly looking at ways we can improve existing data sets, but also develop new products. We do rely on customer feedback to understand how you use the data and what data you need or wish you had. So this is crucial to our innovation to ensure we are in providing you the most beneficial service possible. In the last year, we have launched 2 new products, as you've seen today, and both of these have been in response to feedback from our customers. This data on hedgerows, tree equity and green space is becoming a requirement and necessity, and we want to be able to help you achieve this and meet your government targets using desktop analysis and data. One project we are working on is species, so before anyone asks, we are regularly asked about this and whether we are able to map species. And as Louise had already alluded to, we are aware this is something that our customers require. We are looking at integrating species into the data set. It is incredibly challenging, but it does remain on our radar and a project we are constantly working towards. If you do have other feedback or any products or enhancements you wish to see, please do let us know either in the chat or by dropping us an email after the webinar. Finally, I hope these presentations today have given you an overview of different applications for our environmental datasets. We have also got a number of case studies on our website and guidance documents and samples if you'd like to take a look at them. As the environmental product specialist, I am available for one-on-one discussions about how you can get the most out of the data or other applications that might be possible, as well as supporting you using the data if it is needed. As Fiona mentioned, I was able to create a guide for Aberdeenshire Council, which is now part of our 330-300 offering. So we are here to help you use that data and get the most out of it. Please do get in contact with us if you have any feedback or to discuss anything today that has been mentioned. The email address on the screen is just our general email, but these emails will be passed on to a member of the Bluesky team who will be able to help you. Once again, a big thank you to our speakers and to all of you for attending.